All right. Welcome, everyone. Thank you so much for joining us today. So what we're doing now is we're just waiting for everyone to join the call. So for the first few minutes, what I thought I'd do is I would introduce myself. So hi, everyone. I'm Aga. I am the organizer of this program. I'm the one who has found all of these students to give these amazing seminars for you. So I used to be a student at Cambridge a while ago now, actually. But yeah, I did my undergrad at Cambridge in computer science. And yeah, I'm really, really excited to have you all here. To begin, like I said, we're just kind of waiting for everyone to join. So I do have a really quick poll to do. So what I'll do is I'll launch that poll now. And this is just super, super easy. It's just about what subjects that you're currently studying. And another question is, have you heard of LLMs before? Because that's the thing that we'll be covering today. So yeah, when you get a chance, just fill in that poll for me. And yeah, we're just waiting for the last few people to join, and then we will get started. So yeah, while you're answering that, I just wanted to say there is a Q&A that you can use to ask questions. And please do feel free while the presentation is taking place to just ask any questions that you have. We'll be doing a few more polls throughout where you can answer our questions. But yeah, if you have any questions for me or for Hannah, who is leading the seminar today, please just feel free to put your questions in there. All right, so we've had most people now have answered the poll, and I can tell you for sure that maths is by far the most studied subject. We've got 98% of you are studying maths. But then the next subject, pretty close behind, is computer science. 84% of you studying computer science. That's great. I guess this is a computer science seminar series, so it's good to know that you have that background. But don't worry if you aren't studying computer science either. That's totally fine. As for the second question, have you heard of LLMs before? We've got a pretty even split. 40% say yes and 60% said no. All right. So what I'll do now that most people have answered, I'll end this poll. I'll share the results with everyone in case you're interested. But now I'll just hand over straight to Hannah to start the seminar.
Yeah, thank you, Aga. So hi, I'm Hannah. I'll be kind of giving a seminar today about language models. And hopefully you actually all recognize that you have maybe used them before very soon. So, and then I want to tell you kind of how they work and want to talk about security and safety implications in our everyday, kind of about it. And just a little thing about my background. So I'm a first year PhD in computer science at Cambridge, and I research AI security. Yeah. So I will go right in. The first question I want to ask you is, have you used tools like ChatGPT before?
Yeah, so we're doing another poll for this. I'm just launching it now. All right, that should have launched now. So if everyone could answer this poll. All right, so got lots of responses already. Almost, we've only had one person say that they haven't used ChatGPT before. So that's really surprising. I would have thought it would be more people than that. What I'll do now is I'll share the results with everyone so you can see 64% use it regularly and 34% say that they've used it before at least once.
Okay,
Um,
wow. I think that's a pretty high rate. Like I really didn't
mm,
think that so many people would be using it. Um, yeah, I wonder also whether people who regularly use it ha actually have a subscription or not, or whether they're using like the free version. Because I know that there's some quality differences. I don't know if you've noticed. But yeah,
mm.
so the second question I kind of want to ask you is, what do you use ChatGPT for?
Yeah, so once again, we're doing this as a poll. So I'm just launching that now. So you should be able to see it. So yeah, if you could type in your answer in there, we'll give you a little bit more time since you have to type. Um,
So, Aga, do you use ChatGPT as well? Like, what do you use it for?
so I used to use it more when I used to work as a software engineer because I think it's quite good for like little oh, how do I format this thing? Kind of similar to Googling. Nowadays, not so much. Maybe if I'm writing like a big piece of text and I'm like, oh, does this sound good? Or can you make this sound better? Uh, but not super often. What about you, Hannah?
Oh, I don't know. I always have like so many ChatGPT tabs open and then also some like Claude tabs open and some DeepSeek tabs. I use any help I can get and I use it for like anything really, up from like brainstorming all the way to like coding often because
Mm.
it's very good at basic coding these days. And yeah.
Yeah. All right. So we've got 100, almost 100 people have answered now. So I'm going to end the poll and share the results. So I'm not sure if you can see the results, but we've got things like revision, help for essays, summarizing long texts, help solving maths questions, answering questions that I find harder to find, finding bugs in code, ideas, brainstorming, formulate writing, lots of code and revision I can see, homework, planning with homework and things like that, writing emails, loads and loads of really good answers on here. The answers are shared, so if you wanted to have a look through them, you can do. Um, but yeah, it seems like lots of different things.
Yeah, no, that's quite amazing. Actually, I was kind of surprised to hear that like maths questions are in there as well, because I remember those days when it was hopeless to ask
Mm,
ChatGPT to ask any maths question, right? Like anything that required any reasoning or logic like seemed to fail. And that has really developed so much the past year, I think. It's been getting so much better. Yeah,
mm.
but then I think like a next question that is interesting to consider is like how much do you trust these answers, right?
So once again, we'll do this as a poll. So just bear with me, everyone. Um, Yep, sorry, I have to stop sharing the results and then now I can launch this one. So yeah, so this is just another simple poll. So you've got four options here. I trust it completely. I trust it quite a lot. I don't really trust it very much, or I don't trust it at all. So yeah, do send your answers in. So far, it looks like a 50-50 split between I trust it quite a lot and I don't really trust it very much. So that's quite interesting, quite divided. Very few people have said I trust it completely or I don't trust it at all.
Hmm.
So I think most people have responded now. So I'm going to end it there and share the results. So yeah, 50% I trust it quite a lot, and 48% I don't really trust it very much.
Oh, that's actually, I think, a quite good result. Like,
Mm,
I'm quite happy to see that not like everyone doesn't really completely trust it. It's always good to
mm,
question like any result you get from a black box. You don't really know how it's working. But then I also know that language models these days can really be very helpful, because they do provide quite good answers, often. So that I think that's a good result of the poll. Um, and I think today I want you to understand exactly why I'm coming from this viewpoint of like you can trust it to some degree, but also probably not like 100%. And there are tasks that it will be better at just because of how it is trained. And then there are also ways to kind of give you bad answers, to manipulate you. And so you should kind of be aware of this. Right. So I want to first start with what is a language model? Because ChatGPT is a language model. And so it'll probably be interesting to understand how it actually all works in the background. So a language model is a machine learning model that aims to predict and generate plausible language. And for example, autocomplete that you all kind of have in your phone or on Word or something like that is also a sort of language model. And these models work by estimating the probability of a token or sequence of tokens occurring with a longer sequence of tokens. And here with tokens, I kind of mean words. You could consider words or like sub-sequences of words. And then like a whole sequence could be like a whole sentence. So if you, for example, consider the sentence, when I hear rain on my roof, I underscore in my kitchen. Then what the language model could maybe provide you with is some predictions of which words would be most probable to fill this underscore. And so it could maybe come up with the prediction 9.5% probability that cook soup should be replaced with the underscore. And then it goes down all the way to 2.2% for relax. And that would kind of maybe give you an indication that cook soup might be the best filler. Um, right. Now I want to talk next about what is a large language model. So ChatGPT is a type of large language model, and what makes it large is the number of parameters. So basically how big the model is. And if I give you like a very basic indication of how a model is structured, it has a lot of layers, and each of these layers consists of quite a few neurons. So you might have kind of encountered matrices in your classes. You can just imagine these matrices being larger and larger, and a lot of them stacked over each other for like one of those super big models, right? And we started in the pre-2020s with models that had like a few millions of parameters, and that was already huge for us, right? And then we went all the way now to hundreds of billions of parameters, which is really getting to the super large language model stage, isn't it? Aga, do you have any comments? I don't know.
Yeah, so I've had a look at some of the questions
Yeah.
just to jump in. But I think this one's quite an interesting one. And it's what made you want to do a PhD in computer science?
Oh, like right now in the middle of the presentation, or should I answer that at the end?
Why not now?
Okay. I think compute like if you really want to understand how machine learning is developing these days, the pace is so fast. Um, you will only understand the state of the art if you are doing research into it. And I felt that was really interesting to understand. Mm, and also like the implications. I felt like if I didn't understand exactly how machine learning was going, I wouldn't really understand enough about what the future would hold for us. And like even if you are doing this type of research, you still don't really know what the future holds for us, but you will maybe have a better indication of pathways the future could hold. Um,
Mm,
yeah, so kind of from the
absolutely.
beginning.
Yeah.
Yeah.
I think that's really interesting. And I think particularly, yeah, the way that AI is headed, it very much does seem to be our future. Um, so yeah, no, that's a really good, yeah, really good reason. Um, we've got quite a few other questions, but I wonder if we should just carry on and then maybe some of these questions will be answered in the next few slides. That's what I'm thinking.
Okay, yeah, yeah. I think I will first do this whole section of like explaining language models, and then we can take a few more questions after that.
Yeah, that sounds good.
Great. So now first, you have a black box, you send some prompts into it, your questions, whatever, you put into ChatGPT, and you get words out of it again. But probably you have heard in your lessons before that computers don't really deal with words. So we need to have a representation that computers can deal with. And so we normally represent a word as some vector and some floating point numbers in a vector. And some kind of analogy, which might give you an indication of how we convert it, is longitude and latitude that we have to describe coordinate points in our world map, right? So, for example, Washington, D.C. and New York, they have very similar longitude and latitude points. And this is an indication for us that Washington, D.C. and New York are very close to each other. And the same is for London and Paris, right? Whereas we see from the longitude and latitude that probably Paris is quite far from Washington, D.C. And so these numbers give us a lot more meaning towards the cities compared to just the words, right? Like Washington, D.C. itself, like if you didn't really know where it was, it wouldn't really give you an indication about it. And like in a very similar way, language models embeds words into some sort of word space, and they want to encode words that are more similar, closer to each other. So, for example, for cat, we might want it to be very close to dog, kitten, or pet in the vector space. Um, and yeah, so researchers have kind of been experimenting with this, and what really started this whole project was Google's Word2Vec project in 2013. And what Google did was it kind of scraped all the Google News articles it had, and then it tried to find which words would always be kind of co-located together in an article. And that would give an indication that probably these words would always appear close to each other. And they kind of trained a machine learning model on this and created a way for us to represent words in vectors. And if you go to the next slide, um, we can see that this also gives us a way to reason about different words, how they're correlated to each other. So, for example, man to woman would be very similar to what we think like king to queen is. Um, or big to biggest is very similar in like the direction that we have to take as small to smallest. And it gives us a sense of reasoning about direction as well. Right. So now
So
yeah.
just quickly, there's been a question from Sophia,
Mhm.
which is what vector databases are commonly used in large language models and who has access to those databases?
Vector databases. Okay, so I think how it normally works is that some big company that has a lot of data, it like it has probably scraped it somehow from the internet. It will train some machine learning model so that it will be able to take in some word and then convert it into a vector. And probably there's multiple companies that do that. So there's quite a few models that you can take for to use this, right?
Yeah, you mentioned one, didn't you? Word2Vec.
Yeah, yeah.
That's quite a commonly used one. Yeah.
Yeah, exactly. Yeah. So that's kind of how you convert a word into a vector. But actually, sometimes if we go to the next slide, it
Mm.
might be helpful if we also knew something about the position of that word in a sentence, right? So probably the position of the word indicates a little bit how that correlates to other words in that sentence and maybe how important that is for the whole sentence. So we encode the position in another like positional encoding. And so, for example, for the sentence, the quick brown fox, the would be in position 0 because we start in 0 index in computer science. And we would try to make the vectors the same size for the positional encoding as well as the word encoding that we did. And then we would add together the word encoding as well as the positional encoding to kind of capture most of uh, what the word represents in a sentence. Okay, now that we know how we deal with words, I want to go in and talk about the transformer architecture. So the transformer is kind of the basic way how language models are uh, structured and trained these days. Um, and we will first think about it as a black box. So if we had a machine learning translation application, this black box transformer, it would take in one language and output its translation in another language. So in French, it would you would input je suis étudiant, and then it would output in English that means I'm a student. It's a kind of black box. If we go in and look further how actually that black box is structured, then we will see that actually it is made out of two components. The first component is the encoder component, and it kind of connects to the decoder component. And then from the decoder, we have the final output. And if we go in even deeper, we can actually see that the encoding component is made up of a stack of encoders, kind of piled on top of each other. And then we also see that the decoding component is made out of a stack of decoders of the same number. And we see also that the final encoder output is fed into each of the decoders. So it kind of gives us a little bit more meaning in a different type of way. Okay, and now I want to talk about what actually the purpose of an encoder and the decoder in the transformer architecture is. Yes, so in the next slide, we see how an encoder looks like, how one encoder component kind of looks like. The encoder's job is to process the entire input sequence and transform it to some rich contextualized representation for every token. And we said like a token, for example, is one word. And how that works is that the encoder first converts each token in the input sequence into an embedding, as we were talking about earlier. And we add the positional encoding information as well. And then it goes through the self-attention layer. And I will talk more about how it actually works later, but maybe it's useful to just know that this attention is a way to incorporate contextual information of that word in the whole sentence. So if we're just looking at one single word in the sentence, we might still want to add some contextual information about all the other words in the sentence. And that's what happens in the self-attention layer. And then in the feed-forward layer, we just apply some more multiplication. And this is just kind of helpful to add to kind of sort through some information. And then finally, we will output out of our encoder layer a sequence of vectors, one for each input token. And this should encapsulate the overall context and meaning of the input sequence. So the encoder has now just dealt with our input, right? But our input normally implies that we want some sort of output. And for ChatGPT, for example, we want our question answered. Or for a translation model, we want it translated to English. And that's the purpose of the decoder. So the decoder generates the actual output sequence, one token at a time, conditioned always on the previously generated output, as well as the contextual representations that we get out of the encoder. So the kind of information that we can get from the input. And how it does the decoder works sequentially. So it first it starts from the start of some sentence, and for each word, it does another iteration of like the decoder loop, basically. And in the first self-attention layer, it looks at all the words it has already produced, so the beginning of the sentence, for example, and tries to predict what kind of word do we need next now that we have already seen these kinds of words. And then in the encoder decoder attention, we actually add all the knowledge that we have gained from our inputs, from our encoder. And we kind of mix it up with all the words that we have already encountered. So now we have two types of information that we kind of start dealing with. And then we do another feed forward layer where we again process kind of the output that we have until then. And finally, the final output should then be passed through a final like linear layer. And actually, this final linear layer will be the size of like the whole vocabulary that we have. So that's like super big, I guess, for the human language, but it will be that size because we will need to give out a probability of which word should be like the next word that we want in our output sequence. So we kind of encode that by indicating everything is some value between 0 and 1, and the one value in the vector that is the highest, that will be like the most probable token to go in next for our output. The biggest difference between the encoder and decoder, I guess, is that the encoder, you can process all the words in one sentence in parallel at the same time, whereas the decoder is a very like sequential process. And you can kind of see this in the next slide, where the picture kind of shows we have three words, je suis and étudiant, and they individually all pass through the encoder to then get some sort of representation out of the encoder at the end of it. Now, you probably haven't really understood yet how attention works because I only said like a rough idea of what it should do. If we go to the next slide, there is some kind of example of how it should work. So imagine you have this sentence: this animal didn't cross the street because it was too tired. Now, what does it in the sentence refer to? Is it referring to the streets or the animal? So that is a simple question to a human, but actually this is not simple to an algorithm, right? And when the model is processing the word it, self-attention allows it to associate it with animal. Um, and this is because it allows it to look at all the other words in the sequence and see whether they have anything to do with it. And it kind of calculates the probability of how much it actually has to do with the word it. So it is a kind of method for the transformer to bake the understanding of other relevant words into the one token that we're currently processing. Now, in the next slide, you will start seeing matrices because we're actually dealing with a lot of matrices here. So the first step in calculating self-attention is to create three vectors from each of the encoder's input vectors. So for each word, we create a query vector, a key vector, and the value vector. And these vectors are created by multiplying the embedding that we got from the word, the vector, by three matrices that we trained during the training process, which are WQ, W to the K, and W to the V. And these are just kind of abstractions that are useful to think with. And we will see exactly how how to calculate with these matrices that we get query key and value to, in the end, get some impression of attention. Okay, now, the second step in calculating self-attention is to calculate a score. So say we're calculating the self-attention for the first word in this example, thinking. We need to score each word of the input sentence against this word. So the score determines how much focus to place on other parts of the input sentence as we encode a word at a certain position. And the score is calculated by taking the dot product of the query vector with the key vector of the respective word we're scoring. So if we're processing the self-attention for the words in position 1, the first score would be the dot product of Q1 and K1, and then the second score would be the dot product of Q1 and K2. So now we start mixing these vectors that we have created earlier. Now, the third and fourth steps are to divide the scores. Here in this example, we kind of divide them by 8. And then we pass the result through a softmax operation. So a softmax, what it does, it normalizes the scores. So they're all positive and they add up to 1. So we, in that kind of way, will know with the score that is closest to 1 that that is the one that has most to do with the actual word. And in the encoder layer, obviously, the word that normally has the highest softmax score will be its own. So 0.88 at underthinking. But it is also useful to attend to another word sometimes because that could be very relevant to the current word. And we can see that through this softmax score. And then the fifth step is to multiply each value vector in the next slide. Sorry.
Sorry, no, I was just going to say,
Oh, yeah.
maybe we can take a pause because there were quite a few questions during
Okay.
this explanation. So one of the first ones was, what do you mean when you say token in this explanation?
Yeah. So I think it's probably the easiest if you just imagine a token to be a word. It isn't really these days how we train models because actually words are not the most efficient way to split up sentences and paragraphs, but you can just kind of think of it as a word for now.
Yeah, that's great. And then another thing that I just wanted to mention is that if you haven't come across the dot product before, don't worry. It's just a type of operation that you can do. It's a little bit like multiplication, but you don't need to really know the details for this. And then there's another question here that asks, is the score always divided by 8, like it is on the slide here?
No, it isn't. It actually depends on some, like, it depends on how many, uh, it depends on like the number of rows, I think, in the matrix and stuff like that. So
Mm-hmm.
it just depends on the overall size of the model, how, with what number we're going to divide.
Absolutely, yeah. So those are the main ones that I wanted to just talk about right away, just while we're on this slide. But what we'll do is we'll kind of go through the next few slides and see if those the next few slides might answer a few more questions. And then after that, we'll do another pause and we'll answer a few more questions because I can see there are loads and loads of questions, which is great. But we also want to give Hannah some time to be able to showcase the stuff that she's prepared. So yeah, take it away. Back to you, Hannah.
Okay, right. So then the fifth step is to multiply each value vector by the softmax score. You can see that as the second to last step. And then that will kind of drown out the words that are like less relevant, and it will multiply a little bit more the words that are relevant. And then overall, we sum up the weighted value vectors, and this produces an output of the self-attention layer at that position. And this kind of overall can be summarized into the equation you see on the right side. All those steps that you have can be summarized in that mathematical operation there. Right. Now, attention normally actually is applied multiple times for one token, so for one word. And we call multiple applications of this attention thing heads. So it's kind of like trying to look at the correlation between one word, but with all the other words in a sentence in a few different perspectives, right? And all the different perspectives will add some value into how to understand the word in some sentence. So that's basically what these heads do. And this is the different matrices you see there from W0 all the way to W7. So in this example, we kind of have multiple 8 heads. And this is overall just kind of another step from beginning to the end of the attention layer walkthrough, where we start with some input word or sentence, and we embed that into some vector. Then we do all these multiplications and calculate the attention, and then we concatenate all the results from different attention heads together to then kind of finally output our final results. Right. Maybe I will just kind of skip the slide because we don't really have that much time. Now, I want to just kind of walk through a full example for how this actually now works. We start with our inputs, right? And that is embedded with some time signal, and then it goes through the encoders. We get out some sort of vectors K and V, which are the attention vectors, and these are then used in the decoder part. And they are used in different parts of different decoders that will give them different types of meanings, because each decoder will probably have a different sort of view on our on what we should output. It will give us more information. And then in the next slide, we continue with the decoder part, because the decoder then starts predicting output words with this information. So you can kind of see the walkthrough, how it is slowly starting to output "I am a student" in here. And that is kind of basically it. And I just want to do a little recap now about how we actually get from the final layer back to words. So as I was saying earlier, we have some vector output, and then we will pass it through some linear layer, which will spread out our output into the whole space of different words that we have. And then we will calculate again the softmax over it. So we will get probabilities between 0 and 1. And the one with the highest probability is the one that we will pick. And we will know how to translate it from the vector, because the vector that we get finally kind of there's a translation table from that vector back to words that we humanly understand. And I give you a small example here where we, for example, only have a vocabulary of 6 words. And in this example, if we are wanting to represent M, we would have 0, 1, 0, 0, 0, because M only corresponds to that second one that you see, that position. And so everything else doesn't have anything to do with M. So we give it a 0. And how now training actually works is that we want that kind of probability to actually give us exactly the desired output word. So in an untrained model, we will have that all the probabilities for all words will be about similar. So maybe 0.12, 0.1, something like that in this vocabulary. Our desired output will be that if we, for example, want thanks, that it will give us the highest value one for thanks. And so uh, this is what we kind of do is we just kind of minus how big is the difference between our desired output and this untrained output that we have. And we try to minimize that all the time in a lot of training steps until we start getting more desired and correct results. And in the next slide, I give you kind of a walkthrough if we have a longer sentence. So, for example, a correct output might be I am a student and then end of sequence. And in a trained model, we hope to see some scores along these lines so that we can actually output a sentence that makes sense. Yeah, and that was kind of it of like how a language model works in, I don't know, 20 minutes or
I whistle stop tour. Yeah, so that was quite speedy, and we went through some quite advanced sort of topics in that. So if you didn't manage to like catch all of it the first time that you heard it, that's absolutely fine. Like don't worry. I remember particularly for me when I first heard about attention, I don't know, it took me weeks to finally kind of get to grips with exactly what it meant. So yeah, really, really don't worry if you're not quite grasping it yet. There was a question in the chat which was, are these recorded and would I be able to rewatch this? And the answer to that is yes. So all of these seminars are recorded, and once they're uploaded, we will send you an email with them, so you can watch back if there are any bits that you want to see again. Another question that I saw that I thought was quite a good one. This was asked quite early on, but then asked again more recently, which is why do we bother with using vectors and matrices? Why couldn't we, when we embed words, just make them into numbers, like binary numbers? Why do we use vectors instead?
So if you have binary numbers, like probably there will be a lot of words that have the same number. And also a vector kind of gives you a little bit more complex information about relationship between different words, right? So if you only have like a two-dimensional space, you will be limited to, for like the space example we had, like longitude and latitude. But if we actually were able to embed like more information about these cities, like something about like maybe the population, something about like the sort of people living there, what types of jobs are popular there, like that would give us a lot of information that we could then use to correlate whether other cities are closer to it in terms of population, in terms of uniqueness, I don't know, in terms of ethnicity. I don't really know what else you could compare like different cities with, but that is the kind of analogy I kind of see.
Yeah, yeah, I think that's a really good way of putting it. So yeah, you just get a bit more, I guess, a bit more of a detailed description, I guess, when you're using a vector instead of just a number. So someone was just asking if you could clarify what the softmax layer does.
Yeah. So the softmax, what it does is it like kind of normalizes all the values. So you probably have like some values, outputs that are like negative or like highly positive. And then it's really hard to deal with very diverse range of numbers. And to be able to deal with them better, we all squeeze them into the range between 0 and 1 with the softmax. But we want to keep the spatial distance kind of between these. And that's basically what the softmax does.
Yeah, awesome. And then another question, which was um, sort of when we're going through this training process, what if there are two words and they have exactly the same probability? Which one do we choose?
We just choose one of them sometimes and the other times. So actually, like we don't always choose the one with like maximum probability, how it is in reality, because we don't have as clear-cut probabilities like that usually. We give it a little bit more flexibility. Um, and so we can sometimes take like the top K options for the first output and then try to see how that transitions into probabilities for the second and third word. And only after we have collected quite a few of these probabilities and then we have kind of compared overall for maybe the last word, how probable that now is, then we might have a better pick of um, the whole path of words we want to take. And that's the kind of like search that sometimes we do. Um, and sometimes we also, yeah, just pick randomly one of the top K words.
Mm. And then another question that's kind of a little bit similar along the same lines, which is if you're translating words and one word will translate into multiple words, how does a decoder deal with that?
Yeah. So I think the attention is kind of the key to this because attention allows us to see the whole context of that word. So there are some words that have double or triple meanings, and we can only deal with them as a human also because we have a context in which the word is used. And what attention does, it enables the language model also to see that kind of context.
Okay, perfect. I've noticed we have so many questions, and there's no way that unfortunately we'll be able to get through all of them today. So what I might say, even though all of these questions are really, really good, genuinely, I'm looking through them, and a lot of them I'm like, oh yeah, why is that the case? Because we haven't got much time left, I will let Hannah continue with the seminar. Um, and then what we'll try and do at the end is we'll try and pick a few different questions from slightly different areas to cover, and we might run over by a little bit. But I think that's the best way to go forward. But yeah, please do keep sending questions in. But unfortunately, we might not get to all of them. But yes, please do carry on, Hannah.
Yeah, so I'm definitely not insistent on using all the slides I have prepared. So,
Mm,
but I think like what I want you to take home from learning about language models today is um, these like word by word prediction, right? So what a language model basically does, it predicts the probability of which word should come next. That's all it really does. So if you think about it solving maths questions, that's actually crazy, right? All it's doing is it is trying to predict what word should come next by seeing the input question and by seeing what other words we have already output. Um, and that kind of leads us to the question of like, are there any like potential dangers when we
mm.
use these models?
Absolutely. And this is something that actually someone has asked, what do you think personally are some of the limitations of language models? So we do have actually a poll for this to see if you can think of any dangers. So I will just launch that now. So that should be up now. So now, yeah, like Anna said, we've covered how language models work. Can you think of any potential issues? Just jot your answer down if you can think of anything. So you've had a few responses so far. I wonder, while everyone's doing that, maybe we can answer another question in the meantime, if
Yeah.
there's anything. So what's another one? So is attention always reliable in what word it chooses?
You mean that the overall like language model outputs? Or because the attention itself, like it will just give other words in the sentence a score of how much they correlate to the word that we're actually looking at right now. And obviously all of that, like the scoring as well as like the final output, they are like not always reliable. It like depends on what kind of data you have trained on. So the type of data you will be training on is like input and output pairs. So when you see some sort of input, then it should give you that kind of output. That is what you're going to be training on. And so if those input and output pairs are not very good, then that could give you like potentially wrong scores. And there's just such a diversity of inputs and outputs you can have that you could like never guarantee for it always to give you like the correct answer, I'd say.
Yeah, okay. That's great. We've had most people have responded to the poll now, so I am just going to have a look at some of the answers. Um, so someone has said they could be biased depending on the data set.
Yeah,
Uh,
that
do you want
that's
to say anything about that, Hannah?
yeah, no, that's actually so true, right? Because a lot of the data that they actually train on is just some data that we find when we're browsing the internet. And we know when we're looking at social media posts or when we're looking at Reddit or whatever websites that we use, like a lot of those things aren't necessarily correct. And a lot of those things will have gender stereotypes and um racial stereotypes and things like that. Like a lot of comments might be kind of racist that you find out there. And we still use them as training data, right? So
Mm,
obviously they are trying to develop methods to filter this out, but like yeah, bias definitely.
absolutely. So another person has said they use a lot of resources, so have a large carbon footprint.
Yes, that is also very true. That is a very big problem. So because we have like this huge parameter size, these huge model these days, it is actually becoming very hard for university labs also to train on them and to train anything. And there's only very select companies in the world that can even train a whole language model from scratch. And it is a big environmental problem as well because it uses so
Mm.
much compute.
I mean, that links to a question that was asked in the chat, which is how long would it take to make a large language model from scratch?
Uh, so that like definitely depends on like how many computers you stack in parallel kind of and that you can use at the same time. So training you can actually distribute on a lot of computers. What I'd say, even if you have a whole stack of computers, probably training from scratch will take like weeks, definitely these days.
Mm.
Yeah.
Let's have a look. Another thing that a lot of people mentioned was things like security breaches or security or ethical risks, things like that.
Yes, exactly, exactly. So, in terms of security, you can imagine that data is poisoned, in some sort of way or manipulated in some sort of way. So it will always output you, answers how the people that poisoned the model kind of wanted it to output. So it could maybe recommend you the wrong type of medicine when it should have recommended you, Tylenol or something like that. But you could also have other dangers, such as ChatGPT is allowed to access websites, for example, and then it goes on a website, it clicks on a website, and it gives you some information off that website that it shouldn't give you, that you shouldn't have access to. Maybe it gives you some passwords. Maybe it executes some things that it shouldn't execute. Maybe a language model also maybe shouldn't give you answers to some sort of questions, such as um, how to build a bomb. And a
Mm,
lot of these model providers, they try to build safeguards so that it will not answer those kinds of questions. But then there are a lot of types of ways that you can manipulate the model that it will actually start giving you back answers for these. So a lot of security issues there.
absolutely. And then another thing that has been mentioned quite a lot is incorrect information or misinformation being output.
Yes, exactly. So Uh, I think if you now use the function which connects you to search, to online search, when you're using ChatGPT, then it will start to give you some sort of like citation or like a link from which website it has taken that information, which is a better step, I'd say, towards like factual correctness. But then if you don't use that function, it will just output you some information it has scraped from somewhere. We don't know how it has processed that information, and how it has prioritized what type of information will give a better answer to our question, right? And
Mm.
there might be like ways to manipulate this as well, kind of like search engine optimization in Google, like which websites are going to be ranked first, versus like which websites are going to be ranked at the very end, like nobody's going to see.
Mm, mm, absolutely. And then another one, I'm really impressed, by the way. All of these potential dangers are really, really good. So lots of people saying things like plagiarism or using training data that was stolen. And someone else has mentioned a continuation of stereotypes or a lack of change in ideas.
Yes, so stereotypes definitely are, I think, come come up even more if you do language model training. They are exasperated, kind of. Um, the other point, what was it again?
So if the data has been stolen
Oh
or
yeah, so data, stolen data. I mean, it's kind of interesting to talk about stolen data because uh, the owners of data are us normally, probably. We're the people who put some of our data on the internet, and there's some kind of terms and conditions we kind of agree to. Then some big companies start using that data. And then these big companies start suing other companies if they think that they have used this data. But do these companies even own that data in the first place? So I think one big issue that was on the news was how was DeepSeek trained? And OpenAI was kind of accusing DeepSeek of still stealing a lot of their data. And I think what actually probably happened is that they used probably like ChatGPT or Gemini, so the Google model that they had, and they used the input and output that they got out of these models to train their DeepSeek model, right? And that is kind of a way of using their data. But then also, I think it was just never owned by these companies from the start. So, yeah.
Yeah, absolutely. So yeah, lots and lots of answers there. But I think we've covered sort of the main sort of groups of answers that we had there. So since we're running quite low on time, I suggest maybe we just have a look at some questions now.
Yeah, sounds good.
So I've seen some really, really good questions, but I just now need to find them. So, for example, someone has asked, do you believe tools like ChatGPT will ever be able to be entirely factual? What can we do to ensure this?
Yeah, I don't think it will ever be entirely factual. This is it starts with the problem of filtering data. If the problem of filtering data had already been solved, our internet would be a lot cleaner. We would have a lot less extremism on the internet, that we still see. And yeah, I don't think I don't think we will ever have only factual stuff. But this is also because um some things, maybe some answers to questions are not, there's no right or wrong. There's maybe only opinions.
Mm, absolutely. And then another question that we had was how could we train models to remove bias?
How can we train models to remove bias? Well, we can exclude some examples in the data set that we think are extremely biased. Maybe we have more data of some sort compared to another sort. So maybe we have more data on some males doing something, like males being doctors, compared to females being doctors. And so we might find that in the data set and then filter a few of the examples that males are doctors out of the data set. Um, and that would be like a very simple approach. Um, there's a lot of different approaches to this, and it is still a hard problem to deal with because it's just hard to find all these biases.
Mm, yeah, definitely. Um, and then a bit of a simpler question to answer. I realized that the one I just asked was, yeah, quite a big area of research still, is what is the difference between a large language model and generative AI?
Oh, well, so a large language model is in the subgroup of generative AI, I'd say. So generative AI is all models that kind of produce some sort of new output. So we can have that in image space, in video space, in language space, in sound, like audio space. Um, and there's models in each of these spaces that can generate new music, new images, new videos, like deep fakes and stuff like that. And then language models, of course, they produce new text.
Mm. Um, and then another quite interesting question here, which is who should be held responsible if AI were to go wrong? For example, recommend the incorrect medicine and make someone unwell.
Yeah, that's a not solved question.
Mm,
Um, that just depends a lot, I think, on the lawmakers in different countries. It's like debated everywhere right now because I think model providers they say, oh, like we never said anything about the quality of the content. We just said that we will um give you a model that can produce some answers. We never said that all of them were correct. You're the one at the end of the day if you kind of follow these instructions. And then yeah, I mean, there's like different ways of seeing that, and probably the middle ground will be the way to go, where some partial responsibilities will be on the model providers. It's also a reputation problem for them, obviously, if they keep telling us like wrong things and unsafe things. And so they will have some kind of benefit to trying to mitigate this. And then is also our own human responsibilities if we do any action from any recommendations that we get from these models, right?
mm. Another question is how do you make the output from an LLM be more human-like, like as if it's a conversation? How would you do that?
Well, I mean, you just train on more data that is kind of human-like. So maybe if you have a lot of chat data, Facebook definitely has a lot of that. So, well, Meta, they have a lot of that. So they could just train on all the interactions that they found in different chats.
Mm-mm, definitely. Slightly different one, which is what, in your opinion, is the most exciting possible use for AI in the future?
Hmm. Uh, I don't know. I think at the end of the day, it's how we can combine the AI with us humans, and whether we can start constructing new ideas if we cooperate together. Um, it was said always that these models can't be creative, but then it's always like, what's the definition of actually being creative? That is another question. And um, I do think these models enable us to be so much more efficient. So the future will be a lot more efficient. We have a lot more time for other things. So the big question is, what are these other things going to be? Are they probably going to be about creativity, about like new ideas that we want to explore? And how much better will these models be compared to humans? Are there areas these models are not going to be good at compared to humans? Or are the models going to be a lot better than humans? I don't know.
Mm. And then another question. I guess it's half question, half a bit of a statement, which is it actually possible to remove bias if it's created by a human? Surely removing it would initiate more bias based on the developer's view.
That is actually very true. So
Mm.
I think actually quite a bit of bias, especially in the early days in machine learning, was added by the programmers. So because a lot of these developers were white and male, right? So that already added quite a lot of bias into how these models' outlooks were into life. Um, and yeah, so bias is just very hard problem to solve, I think.
Definitely, yeah, definitely. Um, I guess another quick question would be, how do models handle words that are quite rare or you don't see often?
Well, they train on lots of data. They train on like basically the whole internet. So they probably have encountered it at some point. If it is in a language that is not that much spoken, maybe, then it will translate it from one language to another. So it might have done the thinking in English, but it does have in its vast data some sort of dictionary, probably, because there's a lot of books that are dictionaries, and it's probably in the training data. So then after it has done the thinking in English, it might do the translating into that very minor language where there's like that very minor word that it hasn't encountered in any other context.
Mm-mm. Another question, I guess it's quite open, but generally, how would you evaluate a language model? Are there any key metrics that you would look at?
Yes, yes. So there's very hard set benchmarks for this. Or I don't know how hard set because they're changing quite a lot these days just because language models are getting better and better at things. But one of the benchmarks that language models struggled for a very long time with are these maths and reasoning ones, like science questions as well, like physics. Um, and I think very famous data sets are like Math Olympiad questions, um, and postgrad level like science questions, like um, coding benchmarks, how well it can um, write its code for some question, like write a complete program. Yeah, those kinds of things.
Mm. And then a really quick one, because we've been talking a lot about training models on different types of data, and someone just has asked us to clarify, what does it mean to train on data?
Um, it is to try to make the model learn on the distribution of the data. That's what we optimize our loss to be. We want it to um, learn best to give us exactly what the data gave us. So
Mm.
yeah, I don't know. I hope that makes sense.
Yeah, yeah. I think also a more low level answer would be that yeah, very simply, when you're training a model on some data, you are giving it that data so that it can look at it and it can kind of sort of analyze it. And now that it's seen it, it kind of has a better understanding almost. I guess maybe understanding is not the quite the right term, but that's how I think of it sometimes. Another question, which is, what are the main skills that you'd need to study or go into the AI industry?
Um, into AI. Well, I think it would be helpful if you did computer science first. If you knew some basics about programming, but also just kind of theoretical computer science things, how computers work, how memory works, how processors work, what kind of data structures there are, sort of like algorithms that have been used to solve traditional program problems. They are all very useful basics to know before you start going into machine learning. Oh, and then specifically, if you for machine learning, it's very important to know enough statistics, um, data science kind of stuff. Yeah.
Mm. Yeah, yeah, definitely. I mean, I'll always be happy with the answer, study computer science, because that's what I'm trying to get all of you guys to do. So we've got two quite similar questions, so I'm going to group them together. Someone is asking, do you think it will ever be possible to create fully sentient or close to sentient life through AI, as in the AI being able to feel or mimic human emotions? Um, and then a very similar question, which is how far do you think the training of LLMs can go? Can they grow to become more than just chatting and other stuff that they do at the moment?
Yes, they can definitely grow to become more. Um, like a year ago, everyone was laughing at its like mathematical problem solving skills, and it's getting really, really good now. Um, Probably it's going to expand on a lot of more areas, and it is going to get very good at them. As for AIs being sentient, well, my view is probably not because I'm a computer scientist at the end of the day. As I told you, this is how language models work. They do a next token prediction. They predict what should be the next word. Um, they can definitely mimic our emotions because that's like just learning emotions from the data that it has to train on. I don't think it will become sentient and try to do its own thing. But I know that there's a strand of people who do believe this.
Mm. So yeah, just taking note of the time. I'm going to say we will just do our last few questions now. But yeah, thank you so much, everyone. We've got over 200 questions, which is incredible. And they're all
Really?
really very varied. So yeah, thank you so much for submitting them. What I might do is after this, I will go through all of the questions that we haven't answered, and I will take not all of them, unfortunately. I can't promise to answer all of them, but I will take a few different questions that I've seen that have been asked a lot, and I will either try to answer them myself, or I might send them to you, Hannah, just to answer, and then we'll send that as along with the recording for this session. So yeah, right. So for the last three, let's say three questions, we'll do it, and then we'll finish up. Um, the first one is, what are some of the applications of these models in different fields, and what are researchers currently trying to understand about its limitations as well as the potential advancements of AI?
Yeah, yeah. So, potential applications, I'd say like very vast. So, what a lot of people are thinking about is how to automate tasks. So, a language model kind of is also given tools. It can access web browsers, it can access servers, it can run its own programs after it has written them and give you outputs. That's actually what ChatGPT already does for you. So if you ask it to compute some graph with some data, it will do that. It will write some code and run the code on its own servers, and then it will output you the corresponding graph. Um, in other fields, well, I think people are also thinking about using language models kind of as the brain for robotics, drones, cars, those kinds of things. Yeah, I mean, I think the only problem is that language models are quite big, so that is limiting it to put it into very small applications, but yes. And then as for what we're thinking about researching, we are thinking about understanding what is actually happening inside, how the representation space actually looks inside the model. It is still mostly a black box for us because we don't know how they're actually connecting different concepts and words. Um, we don't know in which layer, in which neuron, it is actually giving us the intuition. that the answer to some question might be like Golden Gate Bridge or something like that. So we're trying to understand that. Um, and by understanding that, also try to mitigate bad aspects of the language model. So safety issues, as well as like mistakes. It does. And one big research area is just how to make them smarter, I guess, how to improve training. Are there any new types of architectures? So today we talked about transformers, but there's a lot of different architectures that have been debated over years and new ones coming out all the time. Whether any new ones might be more efficient and maybe language models might not be the way to go. Maybe in a few years, we will think about like totally different type of model.
Mm, absolutely. I think, yeah, the thing about AI and large language models is I feel like, yeah, things have changed so much so rapidly in the last few years that I've seen there's a question someone's asking, what do you think will happen in 5 or 10 years? I think it's quite difficult to answer such a question because if I think 10 years ago, I don't think I could have ever imagined like ch even just ChatGPT and how good that is at certain things. So it's yeah, it's quite a difficult question to answer, I think. I'm not sure if you have any inputs to that, Hannah.
No, I actually don't really have any idea about that. I mean, right now we're still like very behind on robotics. I don't know if there will be some sort of revolution very soon on physical aspects where you kind of use the AI as a brain. Mm, yeah, except for and then I think it will just change a lot about the work culture as well, like what types of work are actually um useful, what type of people we want to employ. So like 3 years ago, software engineers were so useful, like we needed a lot of them. Right now, these language models are getting so good at coding. A lot of big tech companies are firing a lot of software engineers. So maybe something like that will happen very soon again for different types of people.
Maybe, yeah. Two questions I've got lined up, and then we'll finish, I promise. I'm sorry, I just keep getting distracted by all the great questions that are coming in. Yeah, so one question we've had is if we wanted to learn more about training models, building and training models, and also just generally learning more about AI, are there any sort of books or websites or other resources that you recommend?
Wait, I'd say before you start thinking about training a model, it's probably good to learn Python. Python is the major language that we use to write code for machine learning. Um, Python, there's a lot of tutorials online as well as there's also books you can use. Um, Machine learning, well, I don't really have any particular tutorials in mind, but I'm sure there's a lot of online resources. You probably will start any machine learning tutorial with not language models, but you will probably start with very classical machine learning things that kind of maybe is more of a limited problem, like classification of some images or classification of some sort of data in very limited, maybe 10 sorts of classes and those kinds of things. And I think that might also be useful before you start learning about language models, like the crash course today. But I'm sure there's a lot of YouTube videos out there you can also watch. Yeah.
Yeah, absolutely. And now, just for our final question before we wrap this all up, is there a possibility that humans will over rely on AI? Do you think there's a point where AI should stop being developed any further?
Mm. Over reliance, definitely, I think already happening. I mean, every time there's a buzzword, how it happens in business is businessmen flock around all the buzzwords and they as they did with blockchain, they used blockchain for everything, although a normal database would have been fine. They use language models for everything, although different other machine learning models would have probably been okay, or maybe even some algorithm would have been okay. Um, and then also definitely something that we need to keep training. I think that it's like part of education that we need to really focus on is that we ourselves learn to critically assess answers that are given by these models. If we don't develop at the same pace as these models, then at some point we will become too dumb to judge whether an answer is actually correct or usable, and in what sort of way. Yeah.
Mm. I think another thing that I just wanted to mention before we finish up is we've been talking a lot about how AI is doing lots of different things and how it's getting really good at it. And before you kind of get really scared and worried that once you get to the job market, everything will be done by AI, I wanted to just really briefly talk about the fact that sort of just around the Industrial Revolution, when loads of machines were starting to take over people's jobs, there was a very similar sort of outcry where people were like, oh my goodness, all of these machines, they're ruining everything, they're taking everybody's jobs. But of course, it's been, 100 years and people still have jobs. And so that's the thing to keep in mind is like, even though AI is developing and it will probably do some of the jobs that people do now, it will never cause people to stop having work. Work just might change and adapt, but we'll all still have jobs. So that's not something you need to worry about. Um,
Exactly, yeah. So I think learning to be like think flexibly and learn more about how to think and which ways to analyze things, that's going to be helpful for different types of jobs. That's not a skill that you can only apply to one job, but like the sorts of like structured thinking that you learn in maths or in programming as well, like that can be applicable in a lot of different contexts. Also, like when you want to develop a business, how to structure, to think about that, how to make a plan. Um, and I think that is basically what should be your goal for university. This is why a lot of university grads don't actually go into the area that they have studied, but they go into a lot of other jobs that they might have not considered at the start of their undergrad. But what they have hopefully learned through their uni time is to do this kind of critical thinking, you know?
Mm, absolutely. And with that, we'll finish off. Sorry that we've overrun by quite a bit. Thank you so much for coming and for all of those amazing questions. I hope that you have learned something. You've left this talk knowing more about large language models than when you started. Like I said, I will have a look through these brilliant questions that you sent in, and I will send up a follow-up email with the recording of this session and an answered selection of questions. But unfortunately, I will not promise to answer all of the 200 questions, even though I'm sure they're all great. Yeah, thank you so much. We'll be ending the session here. But yeah, I hope to see most of you next week as well. All right. Thank you, everyone.
Yeah.
Bye.